Alright students, here we go. This first one, we're going to take it and we're going to rotate it about that y-axis. We got a rectangle, it's going to rotate real fast, it's going to give us a cylinder. When we look for the volume of a cylinder, it's just base times height. So our radius here is going to be 3. So we'll have pi r squared h, base times height, pi r squared h. Radius is 3. Height is going to be 4. 3 squared is 9 times 4, give us 36 pi. And we'll slap on a units cubed just for our unit friends. Number 2, we got the paint roller. This one, you're looking at the lateral surface area. Those ends are not going to matter. So we have perimeter times height of the first, the perimeter times the height of the second one. We want to know which one's going to spread more. So I've got just pi d times h. Pi d will be my perimeter. So pi times 2 for the first one, and then h is 11. Pi times 3 for the second one, and then h is 7. So this is going to give us 22 pi for roller A, and then 21 pi for roller B. Roller A is going to be bigger by 1 unit of pi. On number 3, we've got a cold capsule. It's going to be 11 millimeters long and 3 millimeters in diameter. We want to find the volume. So I'm going to take it and split it up into 2 shapes. I'll have a cylinder and then I'll have a sphere tagged on the end. Half the sphere is here, half of it is here. So put them together, you get one sphere. 4/3 pi r cubed is going to be our sphere volume. So make sure this is the diameter. When you get that r, it's going to be half of your 3. So this is the volume of your sphere. We're going to add on to that the volume of the cylinder. In the middle, again, watch out, the height of that cylinder is going to be 11. Base times height, we'll get pi r squared for the base, or for the base. And then we're going to multiply it by height, which is just 8, because we had that diameter of 3, 1.5 on each side, and it's going to cut off from that cylinder. You're going to multiply all this out, you get 22.5 pi millimeters cubed. It'll look just like that. On this one dangerous. You've got this rocket, you're going to find the volume. Finding the volume is not hard. The cylinder on the bottom, we've got base times height. So I'll have pi r squared times height. Remember that they're giving you the diameter. And then plus this other one, they give you the slant height. You want the actual height. So if I take that cone, look at it from the side, it's got a slant height of 17. I'm going to drop this down so I get my right triangle. You've got a length down here of 8. You can do Pythagorean triples, you can do Pythagorean theorem. You can find that height of 15 right here. So I've got 1/3 base times height. My base is going to be pi r squared, and then my height is going to be 15 from this number. Now when you get this, you're going to add this all together and you're going to get 3520 pi, and you're going to multiply this by 0.6, and you're going to be like, yes, I got it. And then you're going to be like, no, it doesn't match the answer. And that's because 60% contains fuel and they want the portion that contains the other equipment. I did that as well. So we're going to not multiply by 0.6, but we're going to multiply by 0.4, and that's going to give you the answer that you're looking for at 1408 units cubed. So be careful on that one. Make sure you read the whole question. Scoodle-a-doo. Next question. This one, we got a tunnel, let's say 100 feet long. Cross section is a square with a semicircle on top of it. So I'm going to take a look. It looks like this. We got 24 by 24, and I've got my semicircle on top of it. What is the volume of rock they're going to pull out? So this is just going to be base times height. I'm going to have 2 base times heights. I'm going to give them my top and my bottom. Oh. There we go, top and the bottom. The top, for base, I've got 1/2 of a circle. So 1/2 pi r squared, the diameter is 24, so my radius is going to be 12. So half of that is going to be my top. And then I'm going to do my bottom, which is just 24 squared. All right. So since my top has a pi in it, this is the base of my top. This is how long it is. This is the base of my bottom. 24 squared. That's how long it is. You're going to multiply all this together and leave out the pi. Leave the pi in there. This one's going to be 57,600 pi. and then we're simply going to add on to that 460,800, and this is all feet cubed. Cha-cha. An aggressive answer. On this one, just important that we split it up top and bottom. We have our semicircle, so pi r squared h, and then we have our base right there. Number 6, 5 miles long. Critical that you spot that. I had trouble, not trouble. I did not spot it the first time, and I got these answers, and they didn't look around. I was like, what? So you want to make sure that we take that 5 mile, and you want to transfer it to feet. Everything is going to be in cubic feet when we answer this. Cubic miles, you just don't want to go there. So volume of the cement needed to make the pipe. We're going to take the big pipe and we're going to take out the hole. All right, so the volume of the big minus the volume of the small is going to give us that one. So I've got pi r squared h for the big one is going to be pi r squared h, and it's 5 times 5280. We want to go to feet for everything, cubic feet for everything. So this is the volume of my big cylinder. I'm going to take away the volume of my small cylinder, so pi r squared, and again h, which is 5 miles, 5 times 5,280. So I've got the volume of my big minus the volume of my little. This is going to give me the volume of the cement needed to make it. And once you punch this out, remember, drop that pi in towards the tail end, you're going to get 85,800 cubic feet of concrete to make the pipe. For just the water, it's the inside. What's the volume contained in the pipe if it's full? And that's just going to be this number right here. You've got pi r squared h, and it's full of water, so you don't have to take anything away. 237,600 cubic feet of water that's going to be inside. That part was easy. Number 7. This is where it's going to get a little weird on you. All right? They give you this tennis ball volume is 288 pi cubic centimeters. They want to find the area of the label, and they want to find the volume of the air that they're going to suck out. The first thing we need some information about the dimensions. The dimensions of anything. We have only the volume. So 4/3 pi r cubed is going to be the volume of my sphere. I know that's equal to 288 pi. I can drop the pi's, and then I have 4/3 r cubed is equal to 288. I'm going to multiply both sides by 3/4 to clear my fraction. And I've got r cubed is equal to 216. That's going to give me a radius of 6. Once I know the radius is 6, the label is simply going to be the lateral surface area, and then the volume of the air, I'm going to find the volume of the cylinder and take away the 3 volumes for the sphere. All right? And this is just the lateral surface area of the cylinder. Perimeter times height will give me lateral surface area for that cylinder. Perimeter is 2 pi r. And then the height is going to be 1, 2, 3, 4, 5, 6 r's. So 6 times 6, 36. And you're going to get the label area. Is that how you spell label? Oh, they have it in here, don't they? Ah, it is. So label area is 432 pi. And this is going to be centimeters squared because we're dealing with area. The volume is the volume of the cylinder minus 3 spheres. So I've got base times height, pi r squared times h, which again is 36 because I've got 6 radiuses. And then I'm going to take away 3 of the volumes for the sphere. You're going to punch out all this math and you will again get 432 pi. This time, however, it will be centimeters cubed. We'll cut the video right here.